So the goal is now to talk about map, filter, and reduce. Map, filter, and reduce are three functions in Python that bring in functional programming. So the distinctive characteristic is that each of those functions takes another function as an argument. So let's see an example. Let's look at map. So map takes a function and some iterator, so a tuple or a list, and will return a list containing the result of the application of this function to every element of the original iterator. So let's look at an example. Let's take all numbers to be the numbers between 0 and 9, and cubing to be this cubing function. And let's apply cubing to every element of numbers using map. So map means we'll take cubing and apply it to every single element in numbers, and we get cubes. So cubes is here. You see, it's really the cubes of all the numbers between 0 and 9. So this is when you have one argument, which is a function, and the other one is an iterator. But you can have several ones. So you can have several iterators. So here, for instance, I pass a simple function lambda xyz that takes the product of x, y, and z. And I will take three iterators, which are 1, 2, 3, 4, 5, 6, 7, 8, 9. And this will return the product of the product of the three. So you see 1, 4, and 7, 2, 5, and 8, and 3, 6, and 9. So it zips the three together and then takes the product of the first entries, then the product of the second entries, and so on. Okay, so that was for map. Now what does filter do? So filter takes a function and a tuple or a list, and will return all the elements in the original iterator, so the tuple on the list, where the function returns something that converts to the Boolean true. So let's look at an example. Let's look at isOdd, which is this little function that determines whether zmo2 casts to a Boolean which is true or false. Okay, so isOdd 7 would give 1, and if we were to convert this to a Boolean, we would get true. Okay, so if we take the same but for 0, we get for 8, we get false. Okay, so this is a function, and we can filter all the cubes, taking only those that are odd, and this is what this guy is doing here. Now, it's a technicality, but cubes was originally a list, so what we get is a list. If we convert cubes first to a tuple, what we get is a tuple. Okay, so this was map, filter, and now what about reduce? Well, reduce is a bit more complicated. So what does it do? It takes a function and some iterator again. And what it will do is that it will break down the iterator into two parts. So a first part and a second part. And the first part will just be the first entry, basically. And so it will compute the result of applying the function to the first part and the result of reducing the remaining part with the function again. So it's a recursive definition. So it's quite simple. If you think of the function as just taking the sum, if you want to sum a whole list, well, it's going to be the first element plus the sum of the rest. Okay, and this is exactly what I use here. So I will take reduce. Right, I didn't define odd cubes. So I would like to save all those as odd cubes. Okay, and then I will reduce all the odd cubes by taking the sum. So maybe I print first so everyone's with me. So if I print odd cubes, I get those, which are the odd cubes, yes, sure. And then I will take the sum of all the odd cubes. And this is 1225. So it's important to understand how this was computed. The computer figured out, okay, x is 1, and y is the result of reducing this whole sublist with this function sum. And what's that result? Well, it's going to be 27 plus the result of reducing the remaining part of the list, which is starting here, with this sum again, and so on. And so it's a recursive definition, but in the end, you get the sum. So I said that the emphasis on functional programming was to define functions and more complicated functions, to compose them and to do things with them, and to name functions rather than objects, than regular data. This is true, even though in this example you will see that I've named numbers and cubes and odd cubes. So I've actually given names to quite a few of the regular data. But the thing is, to actually map, filter, and reduce are essentially the basic tools that allow you to define a function, a more complicated function, a higher order function, a function that takes as argument functions. But then you can combine them. You can do things with map, filter, and reduce that constructs vastly more complicated functions. And this will require the operator and the functools modules.